Wonderful, wonderful question number 7. This is asking me to find both the perimeter and the area of this polygon ABCD. Clearly, it looks like a quadrilateral. It's got 4 sides. Also, I can tell that this is a right angle, right, because I've got horizontal and vertical lines. But I don't know that I could call this a trapezoid or anything else. So if I start looking at it in terms of the perimeter, I've got this side, which is pretty easy for me to see. This is 1, 2, 3, 4, 5. This is 5 units long. And as I go down from point A to B, I've got 1, 2, 3, 4, 5, 6 units. So this is 6 units long. So far, those 2 sides together are adding 11 units to the perimeter. Let's take a look at the next part. I'm going to extend this over here and here and make a right triangle, because this piece from B to C is now the hypotenuse of that right triangle. I can definitely figure out that length. So if I'm looking at the horizontal piece, this is 4 units long. The vertical piece is 3 units long. So I have a right triangle that has sides 3 and 4. And if I square 3 and add to that the square of 4, I have 9 plus 16, which is 25. And the length of that side BC will equal the square root of that sum. So it's going to equal the square root of 25. And the square root of 25 is 5. So this is 5 units long. So that's interesting. I've got 2 congruent sides now here because of this. The 5, the 5, and the 5. Although this still can't be I don't think it's a kite because DC would have to be 6. So let's go ahead and do that, figure out the length of DC. So I've got 3 units this way. And as I go along the bottom, this is 9 units. So again, I'm looking at this triangle because I need to figure out the length of segment D to C. And I can see here that I have 9 squared plus 3 squared. And if I take the square root of that, that's exactly equal to the length of segment DC. So the length of segment DC is this expression. This is 81 plus 9. So I'm looking at the square root of 90. So I don't think that's not a perfect square. I know that. Let's do that. Let's look at the square root of the number 90. When I do that, I get about 9 point. I'm going to round it to 9.5. So this is about 9.5 rounded to the nearest tenth. By the way, just something I want to start pointing out when we see expressions like this. I want you guys to think about this, because this is, especially as honor students, you should be able to do this fairly easily. If you look at the square root of 90, that is the same as the square root of 9 times the square root of 10. The reason why I broke it down that way is it turns out the square root of 9 is a perfect square, right? It's 3. So the square root of 90 is the same thing as 3 times the square root of 10. This is called simplified radical form. And one of the things we do is we're just looking for perfect squares that are inside of the radicand, and we bring those out. So root 90 is the same thing as 3 root 10. And you can see that if I take 3 and I multiply it by the square root of 10, you can see I get exactly 9.486. So they're identical to each other, just this is called simplified radical form here. Okay, so I think I have all the information that I need now to figure out the perimeter of this. Part of it is there was a 6, there was a 5, there was another 5, and then we just figured out the last segment there, DC, is about 9.5. So if I was to add those, geez, I can do that, right? This is 10, and then 6, that's 15. Okay, so that's 10 plus the 15. So I think we're at 25, 25.5. Yeah, because 6 and 9 together make 15. And then we've got the 0.5. So 10 plus 15 is 25, 25.5. So my perimeter is 25.5. And I'll just put U for units because I don't know how far apart these are, if these are inches or millimeters, but they're units. And we now need to calculate the area of this thing. And to calculate the area, probably the thing that I would do most often is I would just consider this entire massive rectangle that's just 6 by 9. I would just find the product of that, and then from that I would subtract this area, and I would subtract this area. And because these are triangles, they're relatively simple to figure out the areas of. So for example, in this top triangle here, I've got 4 times 3, which is 12, and half of that is 6. So this has an area of 6 square units, so I'm going to be taking that away. And the other place is 3 times 9, which is 27. If I take half of 27, I don't know, what is that? It's like 13, 13 and a half. So this is 13.5 units. So in order to find the area of this whole thing, I'm just basically going to take 39 units, which is the area of the entire, no, 6 times 9. It's not, it's 6 times 9, which is 54. And from that, I'm going to subtract, go away. I'm going to subtract 13.5, and I'm going to subtract 6 from it. So let me see, 54 minus 13.5 minus 6, I get 34.5. So the area of this is 34.5, and these are square units. So why, you may ask? Well, look, if I'm talking about the perimeter, it's a length. That's 1, 2, 3, 4. So this square has an area of 4 units. The area, notice I'm going to multiply units times units, right? So when I multiply units by units, I get units squared. In this case, 1 unit times 1 unit would mean the area is 1 unit times unit, or 1 unit squared. And the perimeter P is equal to 4 units, right? 1 unit plus 1 unit plus 1 unit, so it's 4 units. So same thing's going on here. The area is 34.5 square units, and the perimeter is 25.5 units. Sorry, I made a mess of this problem.